All right, we're going to continue on here. Along with weathering, we have erosion and deposition. Usually, all three of those kind of go hand in hand. Usually, they weather and then they get eroded and then deposited somewhere. So, weathering is the breakdown. We've already talked about the breakdown. All right. Erosion is when those broken down sediments get transported somewhere. They get brought somewhere. And then once they get brought somewhere, they usually end up getting dumped into a body of water, a lake or the ocean or whatever, and that's called deposition. All right. So they get broken down through the process of weathering. They get transported somewhere through the process of erosion, and then they get deposited into some body of water and they can build up there. All right. Now, there are several things that serve as what are called agents of erosion, things that move sediment. All right. These are the big ones. All right. By far, the most dominant erosional force on the planet is running water, streams, rivers. Okay. Well, we've got other ways that sediment can be moved. Wind, glaciers, coastal waves. All right. All these processes serve to move sediment from one place to another. All right. The gravity is kind of the underlying force. Okay. Gravity is what pulls rivers downhill. All right. So gravity is the force that moves all this sediment, or that causes the water to run, which moves all this sediment, etc. But gravity itself can be an agent of erosion also. We call it the fifth agent of erosion. For example, let's say you've got a cliff face that the cliff face breaks off and falls to the bottom. All right, nothing moved those sediments except gravity. All right, it wasn't wind, wasn't glaciers, wasn't running water, wasn't waves. It was just the rock broke and it fell to the bottom of the cliff. That's an erosional force, and it deposits it at the bottom of the cliff, but it was simply done through gravity. All right. So we've got running water, wind, glaciers, waves, and gravity. Those are our agents of erosion. All right, we're going to start with running water. This, by far, is the dominant agent of erosion. All right, and we talked about the water cycle, runoff. Okay, all that runoff that doesn't go into the ground has to go somewhere, and it finds a river and works its way downhill, eventually, preferably toward the ocean. That's where it wants to go. All right. One of the key indicators that an area has been eroded by running water is the shape of the valley. Generally speaking, running water creates V-shaped valleys. Think about the Grand Canyon. This would be the canyon wall, and then the Colorado River would be down here. What happens is over time, it slowly cuts its way down through the rock layers. Right? Creates these steep-sided valleys. Right? So that's a good indicator that you're dealing with running water, is that V-shaped valley. Right? Here's a couple of examples. Grand Canyon, the Catskills. All right? Sometimes you might hear the Catskills referred to as the Catskill Mountains, and that's because they were misnamed at some point. People thought they looked like mountains, which they kind of do, but really what they are is they're a plateau, an area of high elevation that is cut down by water. And so over time, these get worn down right here, and they end up looking like mountains. And they're not really mountains, okay? They're just an eroded plateau. And we'll talk about the difference between plateaus and mountains here in a little bit, all right? All right, so as you increase the speed of a stream, or you increase the amount of water that's in the stream, you're going to increase the amount of material that can be moved, all right? Faster streams or streams that have a lot of water in them can carry a lot of sediment. They can erode a lot. All right? If we look at a cross-section of a stream, you're going to get the stream channel looking differently depending on where it is in terms of a curve. All right? On the outside of a curve, the water actually picks up speed as it goes around the outside of a curve. And because it picks up speed, there's more kinetic energy, and therefore there's more erosion, more weathering and erosion that goes on the outside of a curve. It cuts into the rock more on the outside of the curve because the water is moving faster. Conversely, on the inside of that curve, the speed actually slows down a little bit. And if we have slower water, we're not going to get as much erosion, and so sediment starts to deposit on the inside of that curve. If the water slows down, it starts to drop some of its sediment, and it gets deposited on the inside. All right? Here's a little kind of an example. The dark blue line. The dark blue line shows where the water is fastest, maximum velocity. Notice on the straightaway, it's in the middle. But as you go around a curve, the speed maximizes on the outside. And then it goes back to the middle again. And then it's faster on the outside again. And then it's back to the middle. And then it's faster on the outside. And then back to the middle. All right? It's always faster on the outsides of curves. So there's erosion going on there. Erosion. And then on the insides, there's always deposition. And that's because the water is going slower, and the slower the water moves, the less material it can move, so the stuff starts to fall to the bottom. All right? We'll get a little cross-section. This is what a cross-section would look like. If we could cut down through the river and see what a cross-section looks like, this is what it would look like. So let's start on the right here. Let's look at a top view. Here's the riverbank. Here's the riverbank. This is the stream or the river. All right? The length of the arrow shows the speed of the water. So on a nice straightaway, notice the fastest water is in the middle. That's because there's lots of friction with the bank over here, lots of friction with the bank over here, not any friction with the bank here, so the center of the river actually moves faster. All right? Now, if we were to cut down through that river and look at a cross-section, this is what it would look like. It would take on that kind of V-shaped look. All right? Because it's faster in the middle, it's going to cut into the rock more in the middle, and so your channel is going to take on this little V shape with the deepest part of the channel right here in the middle. All right? This X is showing actually where the water is fastest. It's in the center, but it's actually not right on the surface. All right? It's actually a few feet below the surface, and that's because not only is there friction with the side of the bank here and here, but here there's friction with the air. So the surface is actually a little bit slower. If you go down a couple of feet underneath the surface, that's where the water is actually flowing fastest. All right? All right, let's look at a curve, though. This was a straightaway. All right, look at the shape in the straightaway. Now let's look at a curve. Notice we got cross-section A to B, so we got a cross-section A to B here. On the inside of the curve, this is where the water is slowest, so the sediment starts to deposit right here. On the outside of the curve, the water is fastest, so it starts to cut in and erode right here. So what happens is it looks like this. Notice that deep portion that was in the middle shifts to the outside. It's now deeper on the outside of the bank and shallower on the inside. All right? Our fastest water actually shifts over toward the outside of the curve. It's still a few feet below, but now it shifts over to the outside of the curve, so we get sediment being deposited right here, and it cuts in here. All right? So if I were to superimpose what the channel would look like before when it was on the straightaway, it would have looked something like this. Remember that? Okay? So what happens is all this got filled in with sediment because it slowed down. And this used to be the channel right here. This used to be the edge of the channel, but it got cut in, it got dug out over time by the water until eventually you've got the channel being deepest over here. And this all got filled in right there. All right? So when you draw in your channel on your stream, you always draw the deepest portion on the outside of the curve where there's more erosion. Mm-hmm. All right, this picture I took actually down in Sherrill. If you're going down Beacon Light Road from the school, and as you cross that little bridge going into Sherrill, if you look to the left, you can see there's a little deposition of a point bar, so to speak. This is sediment that was all deposited here, And notice how it's cutting into the side on the outside. Right here, this is cutting into the outside here because it's on the outside of a curve, so it's faster. The inside of the curve here, it was wicked slow, and so sediment started to deposit here until eventually it built up, and now it was actually above, so now the water is over here now. All right? You can actually see this really well as you go down into Sherrill and cross that bridge. All right? All right. Over time, if that stream continues to curve over time because it's cutting in, okay, those curves are what are called meanders. Okay? It's just a fancy word for a curve or a bend in the stream. All right? So over time, over here will start to erode. Over here will start to erode. Here on the inside, it'll start to deposit. So we get deposition here on the inside. And notice how the shape of the river is changing. It starts cutting more and becoming more and more curved over time. That's because of the erosion going on the outside of the curve and the deposition going on the inside of the curve. Eventually, over many, many, many years, hundreds of years, these two edges right here, this one and this one right here, can actually come close enough together where they'll kind of pinch off. And then the water will stop flowing around like this, and it'll just jump across. And it'll cut off this portion of the stream. Now the stream is here doing this. Okay? That portion that's still filled with water, but it's not part of the stream anymore, is what's called an Oxbow lake. All right? It's a lake because the water's not moving, but it was part of the stream. It's just water that's sitting here now. All right? The water jumped across, sealed off itself with sediment, and now the stream's doing this. All right? That's the formation of an Oxbow lake. All right, here's a little side view of how rivers carry sediment. It's called their stream load. All right, this is a side cross section of the stream flowing downhill like this. All right. Dissolved in the water are minerals. Okay? There's minerals, there's salt and things like that dissolved in here. You can't see it. If you put salt in water and mix it up, you can't see the salt. All right? That salt is now dissolved as an ion in solution. All right? That process is called solution. It holds the minerals in solution. If you have small particles of sand and silt and things like that, those don't dissolve in water. They're just particles that can be carried by the water. An example, like if you went down to the beach and you had nice clear water at the beach, but you stepped in the sand at the bottom of the water and you created that cloud that pillows up around your foot, and now the water's all cloudy, you can't see it. Those are called suspended particles. The waters are held in suspension by the motion of the water. It keeps the water from clearing too much. Okay? It keeps it cloudy. And then eventually, you have these large particles that will work their way down also, but because they're bigger and heavier, they don't get carried in up here in the water. They actually roll along the bottom, they slide along the bottom, they bounce and jump and twist and bang into each other and all that. Those are the bigger particles, your gravel particles, cobbles, pebbles, things like that. That's called saltation, all right? Those are the big giant particles that kind of just roll along the bottom of the river, get dragged along. They're not small enough to be carried up in the water, up here, like the sand and the silt. But they do get moved because they get dragged along because the water's flowing. And remember I showed you page 6 before. Remember page 6? Okay. Remember this here? Okay. Those bigger particles up here have to be carried in saltation, be carried by saltation. They drag and roll along the bottom of the river. You got to have a really fast-moving river to get those moving. Whereas your smaller particles, sand and silt and clay and all those, they don't need very fast water, okay, in order to flow, in order to move them. They are carried in what's called suspension, okay? So I call it the 3 S's. Dissolved minerals like salt is carried in solution. Small particles that make the water cloudy are carried in suspension. And then the bigger particles that are too big for the water to really move real well, they can move, but they kind of drag along the bottom, and they get stuck sometimes and all that kind of stuff. That's called saltation. Okay, there's that page again I just showed you from the reference tables. Okay, the bigger particles need a faster speed, et cetera, et cetera. Okay. All right, deposition. All right, this is a little satellite picture showing the Mississippi River flowing into the Gulf of Mexico. This is called the Mississippi Delta. It's that sediment that gets deposited under the water when the river dumps all that stuff into the still body of water. All right. When a stream enters a body of water, its speed is going to slow down. That running water hits that, it hits the lake, and it slows right down because the lake's not moving. And as soon as it slows down, all the stuff that it's carrying starts to get dumped right there at the mouth. All right. And we call that a delta. All right. All right, here's a little example of deltas. They're created by what's called horizontal deposition. So up here in this upper corner, you got the water flowing into the Gulf of Mexico. All right, as it hits and flows in, it slows down. And as it slows down, we get progressively smaller and smaller and smaller and smaller and smaller particles depositing here. Okay, our large boulders and things like that are going to get dumped right away, and they're going to form right at the mouth. Whereas the teeny tiny particles that can get carried by water will eventually get carried out here until the water slows down enough where they're too heavy, and then they start to sink to the bottom and they make layers down here. Horizontal sorting, it sorts this way, okay, horizontally. Deposition can also occur vertically, okay? Like in this picture on the left. Notice the big heavy particles are at the bottom, and then it gets progressively smaller as you work your way up. A good example of that would be, let's say you went and took a wheelbarrow full of gravel and went over to a pool and dumped it in the deep end of a pool. The heavier, denser particles are going to fall to the bottom of the pool first, and then the smaller ones, and then smaller, and then smaller, and then eventually the really, really small light particles will eventually over time settle on to the bottom. And so you'll get this sorting vertically, okay, like this, bottom to top, bottom to top. All right. When we see, if we were to dig down into the ground and we see this going on, this is called graded bedding. We have a layer down here where we have vertical sorting, big particles, small particles, but then on top of that we have another layer with big to small, another layer big to small. We get this when we get areas of repeated floods. What will happen is the area will flood. The particles that the water's carrying will settle vertically. You'll get a layer of rock forming here vertically, and then the water will evaporate away and it'll go away. And then maybe next year it'll flood again, and you'll get another layer sorted this way. We can actually count the number of floods that an area has had by counting the beds. This is one bed, this is another bed. And we can tell how many floods the area has had, but can count them because it sorts itself each time it does it. All right. All right, last thing we're going to talk about in this one is characteristics of stream development. All right, this is a cross section of a stream. All right, up here in the mountains where it's steeper, we have the starting point of the rivers, where they begin. When it rains up here in the mountains, we have a beginning of a river. This is called the head of the river, or the headwaters. All right. That water, because of gravity, will flow quickly downhill until eventually it gets down here into the lower areas where it's not quite as steep. All right. And then it works its way down slowly. And then as it gets more and more gentle, as the gradient gets more and more gentle, the water slows down even more. And then it starts to meander slowly toward the ocean. Water picks its way path of least resistance. Okay? Up here in the headwaters where it's very steep, the rivers tend to be straighter, not as many curves or meanders. But as they slow down on the flat surface, they start to meander their way down and just pick and choose, pick a nice easy path until eventually they dump into the ocean at what we call the mouth of the river. So we have the head of the river up here, and we have the mouth down here. And that's how we label our rivers, right? And each portion of the river, we've got a portion up here where it's steep, a portion down here where it's kind of middle, not really as steep, and then we got a part down here where it's pretty flat. Those places, the river is going to have different characteristics based on what it's doing to the rock underneath, based on what it's doing to the rock it's flowing over. All right? All right, this is what we call a young river. The rivers that are up here, they're steep, they cut down into a lot of rock. We call it a young river. When it gets down here where it's not moving quite as fast and it's not doing as much erosion, we call it a mature river. Okay? And then eventually as we get toward the ocean, we call it an old river. Right? Now these terms, young, mature, and old, they don't refer necessarily to the chronological age of the river. Okay? How old number-wise. What they refer to is what is the river doing to the bedrock. All right? What is it doing to the bedrock underneath that it's flowing over? And that's what we're going to talk about right now real quick. All right? So a young stream. Young stream is characterized by steep V-shaped channels. That characteristic V shape of the river, see that right there? Okay. The channel is fairly straight. I mean, there's some curves and turns in it, but it's fairly straight. We get a lot of waterfalls where the water is just pouring over these escarpments, and a lot of rapids. And the reason for this is because the water is on a very steep ground, so it's moving very fast. All right? High velocity water is going to dig down into that rock really well. It's going to cut down through those layers of rock. All right? Sandblasting, so to speak. All right? During this stage, the energy that's in the river is used for the purpose of cutting down through the bedrock. Okay? It's moving very fast, so it's got a lot of energy, and it's just carving its way right down through that rock, creating that steep channel. All right? Once it moves into a not quite as steep a slope, the velocity slows down. And when the velocity slows down, you're going to get smaller meanders forming. It starts to curve a little bit. Okay? The slope of the river is fairly moderate. You get some Oxbow lakes forming. And you also get this area right in here, which is called a floodplain. Okay? This is the area around a stream that when you get a lot of rain, the water comes over its banks and it starts to flood. So this area right in here is called a floodplain. So whenever the river comes up over its banks, it'll fill that area with water, and then eventually it'll subside and it'll go back down to just being the river underneath. Okay? So that whole area will fill with water. This is where we get those graded beds. All right? Now, in the mature phase, here's what's going on. All that energy in the stream, unlike the young stream when it was all cutting down in, now it's not cutting just down into the rock, but it's also widening that floodplain. It's cutting sideways. Right? So it's digging down into the rock, but it's also digging sideways, and it's making that floodplain wider and flatter. Eventually, we get down into a very, very flat area. Right? And we say the stream is called an old stream. It's old age. Again, not chronological, but what it's doing. Now you get very broad, wide, flat floodplains. Okay? So the floodplains are really a lot wider than the stream itself. Okay? Anytime we get a lot of water when this happens, that whole area will literally fill with water. All right? Very wide, curving, slow-moving meanders. We get lots of swampy areas forming, some Oxbow lakes. And these are all caused by the fact that this water is moving really slowly, just kind of meandering its way down toward the ocean, okay? Picking and choosing its way, finding the path of least resistance. All right? So now we're at the opposite end. All that energy that was in that stream is not necessarily doing any down cutting anymore. All the energy that's in the stream is used for the purpose of widening that floodplain. All right?